at group 3, and in this video recording we will demonstrate uh, creating a data pipeline using Microsoft Azure, extracting the temperature and humidity data from Raspberry Pi simulator, storing that data in Azure Data Lake, and fetching that data on Power BI, and finally visualizing the data using Power BI. This is more or less our assignment 2. Since using physical Raspberry Pi hardware is not at ease at this assignment, so we are using a simulated IoT test data, which represents temperature and humidity readings generated by the Raspberry Pi device. And we will show how data is ingested and stored in Azure Data Lake. We will explain the role of Azure in pipeline and fetch the data in Power BI and create visualization, which will be meaningful for our output.
So we first created a free Azure account, which provides a sufficient credit for this academic project. Inside Azure, we created a resource group, which acts as a logic container to organize all the services used in this assignment. Within the resource group, we created a storage account. This storage account is configured to support Azure Data Lake Storage, which allows hierarchical storage and analytics-ready data handling. Azure Data Lake here is used as a central storage layer where all IoT data is securely stored before being consumed by analytics or visualization tools.
All right, I will now proceed to explain the data ingestion part. So basically the data set that we are using, it represents the temperature and humidity readings generated by the Raspberry Pi simulator, as Akshay mentioned before. So this would simulate the real world IoT sensor output. That's the whole intent. So we created a container inside the Azure storage account, which acts as our Azure Data Lake container. The simulated IoT data file is uploaded onto in this container. And once we upload it, the data becomes centrally available in Azure and can be accessed by multiple downstream tools. So primarily the role of Azure Data Lake here is to act as a single source of truth. And of course, on top of that, we would also want to store the raw sensor data securely. And last but not the least, it is also used to decouple the data generation from the data visualization that we obtain. So this would basically mirror how real IoT pipelines are implemented in industry environments.
So I will now demonstrate how we fetch data directly from Azure into Power BI. Power BI provides native connectors for Azure services. Since Azure Data Lake Gen 2 is built on blob storage, we use the Azure blob storage connector. Using the storage account name and secure authentication, Power BI connects directly to the data stored in Azure without requiring manual downloads. So this enables cloud-based analytics, automatic refresh when data changes, enterprise-grade data access, and once we are connected, we load the data set into Power BI and prepare it for visualization.
So although Sumit told to fetch data from Microsoft Azure, however, due to login restrictions of the account type in Microsoft, same account which was logged in to create data lake in Microsoft Azure was not able to, we were not able to log in from that account in Power as well. And hence, although we would have got the Microsoft Azure through the Azure blob storage here, and by clicking connecting, we would have entered the storage container name. However, since the account is not same, we are not able to fetch that data from there. So what we did was we downloaded that same data which we uploaded on Azure as a simulated data, and we can directly upload the same data which was in CSV format uh, in Power BI as well, and we can run analytics of the same data.
Okay, we see that the data is now in Power BI. Once he loads the data, I'll explain how the visualizations are created in Power BI. The data is still loading. Yeah, now that the data is loaded, we will first need to ensure that the temperature and humidity values are treated as continuous sensor readings. So for these, we use average aggregation instead of sum. And then we created a month-day hierarchy which allows us to analyze the monthly trends and the daily variations within each month. The visualizations include a line chart showing average temperature over time, another line chart showing average humidity over time, and a combined chart to compare temperature and humidity patterns.
So here we have displayed the temperature and humidity, average temperature and average humidity, which is like broken down by month as well as day. And to conclude, this assignment demonstrated end-to-end cloud-based IoT data pipeline, which involved fetching data from Raspberry Pi to Azure Data Lake, and then from Data Lake to Power BI. And then in Power BI, we were able to demonstrate effective visualizations through analysis. And this architecture closely resembles real-world implementation in smart city and IoT, IIoT analytics systems. Thank you.